All right, so what is empty env for? It creates an empty environment.
Got that one.
What is extend env for? This adds a local scope to an existing environment. What is apply env for? Retrieving the value of a variable from an environment. Yeah, if it's not there.
I think I extended that, right?
All right. So, no legitimate excuses for missing that. Because not only did we spend the entire last class doing all of this, it was also your previous homework assignment. All right.
Probably what I got it.
Okay, so let's go back here. So what we're going to talk about today is we want to now take this new idea we have of kind of constructors for building our for building our objects, and go back and start applying it to our lambda calculus expressions. So let me scroll down here. All right, so we're going to start with this idea here. So we're going to break what we've, up to this point, we've thought about our lambda calculus expressions as looking like this, right? All right, so this has been our kind of our go-to grammar for our lambda calculus expressions. So a lambda calculus expression can either just be an identifier, it can be one of these lambda dudes, right? Or it can be a list containing two lambda calculus expressions. Now we want to give a little bit of additional meaning to that. Okay, so when it's just an identifier, we're going to call that a var expression. Just an identifier is a var expression. When it's this lambda dealy flippy, that's going to be a lambda expression. When it's a list of two expressions, it's going to be an app expression. Okay? So now notice that how these start connecting to our programming languages. If in Java I just see a there, we right off the bat assume that must be the name of a variable and we have to resolve it. So it's a var expression, a variable expression, right? In Java, this guy would be a method, right? An unnamed method. Okay, so this would be a lambda expression since we're using the intimidating sounding lambda thing. This would be a lambda expression, which is our unnamed methods. An app expression. What is an app expression? When you think about an app expression, what would you say that is? Think about using scheme up to this point. What types of things have a list where we have a first element and a second element? Predicates? Functions being applied to some operands? So it's an app expression. That is, we're going to take this expression and apply it to these. We'll apply it to that expression. Okay? So typically we would call this the operator, and this will represent the operands. That make sense? If we think about it in terms of an app expression. Okay? So, if I have these new things here, could I create constructors for these guys? Could I create a constructor for a var expression? A constructor for a lambda expression? A constructor for an app expression? Yes, right? The answer is yes. And we should all know how to do that, right? All right, so let's start off with the easy one. Let's go ahead and create a constructor for a var expression. All right, so is this our better or worse scope? This is our, oh, this is Amish's implementation. Yeah, I like that one. I like that implementation. It's kind of a shame. All right, so help me create a constructor for a var expression. Somebody who usually doesn't answer. Now that we're practicing with constructors.
Define var expression.
All right, well, it's right back here.
No, I meant you write define.
Oh, okay, good. I got you. Good. Okay, so we're gonna create something called var expression. That's good. So define var exp. Is it exp or expr? Okay. Okay, so define a var expression. So this guy's going to be a constructor for building an animal, building an object, if you will, that is going to be our representation of a var expression. Just like last class, we built a representation for a variable environment. Okay, we started with an empty environment. Then we extended that by having a constructor called extend-env that took an environment in as well as the crap we wanted to extend it with, and we extended it. All right, I used the book's version of it, and then we all decided that Amish's version was a lot better, so that's why we used the scope stuff. Okay, but same diff. We had two separate takes on a data structure for representing an environment, right? So that was actually a really good exercise we did last class. I realized it was a little heady stuff, but the proof there was that we don't always have to represent everything identically, right? We can have an environment represented with this data structure, or we can have an environment represented with this data structure, and as long as we know how we're representing it, we can work with it. Same thing's true here. I'm asking us to create a data structure to hold the details about a variable expression. So if we go back to the book here, this is a var expression. It's going to be our first production. What information do we need to remember regarding a var expression? Did something funny get posted on Slack? Is that what happened? I take it I probably shouldn't bring it up in the middle.
It's safe to do that.
Childhood memories of yours.
So it's legit to show it on the recording?
It's legit. Hilarious.
No, it's
No.
470.
Just hit play.
He can ride one of these. Oh, that's awesome.
I don't know if it's him. The kid's too skinny.
Man, that kid's just booking around. I have to show that to my wife because she can't ride it yet. She gets on it and she just goes backwards. God, look at this. This kid's 2. He's probably not even 2.
At least he can stand.
That's what we
He might not
think.
be able to walk, but he can stand.
For all we know, he can't stand on his own. This thing's balancing him. That's actually awesome.
Now he's gonna have trouble later in life learning how to walk.
Well, why do you need to walk if you got one of those?
What if you better then?
All right, so for our var expression, what do we need? What inputs do we need to construct a var expression? How about we start off by explaining to me what a var expression is? Pretend this is quiz number 2, and I say, what is a var expression? Tell me what that guy is. What does a var expression data structure represent for us? Huh?
A value.
Oh,
Some value.
okay.
Variable. It's identifier.
Okay, it represents an identifier. Well, because it says so right here. So a var expression is the name of a variable. Right? So how many things do we need to create a var expression? 1, 20, or 3,000?
3,000.
The name of the variable and then the actual value for the variable.
Is this guy taking a value?
I guess not.
But I mean, it's okay to think that way. Because at some point we're going to need to apply that to it. Might that be our app expression? Here's a variable, and here's its value. As we grow our language, we don't really support that yet. But Kind of makes sense maybe where we're going. Somehow we need to have a mechanism for taking a value and shoving it into a variable. Okay? Just like we have with Java, we can say int a is equal to 5. So we have this statement where we have a type, an identifier, a var expression, and a value. Now in Java, a var expression for a var def expression would take in a type and a name, type and an identifier for a var def expression, and then also a value. All right, so we're building our constructor here. Oh, I still got the kid cooking. All right. So this guy's going to be a lambda that takes in an identifier and boils down to what? The identifier. There's our constructor. So now we can build var expressions given an identifier. So I can say, give me the var expression that is A. That's our constructor for a var expression. Okay. Now, next guy, we have a lambda expression. What's my constructor for a lambda expression need to look like? What does it need in order for us to build it?
It's a var expression and then an identifier. Another lambda calculus expression.
Okay, that is good. So we have this guy is actually a var. So this is a var expression. And this guy is a lambda calculus expression. Okay, so we're going to take in two things, a var expression and a lambda calculus expression. So we're going to define a lambda expression that is a lambda that takes in a var exp and a lambda exp. Let's just call it v-exp, just so it makes it easier to. Yeah, whatever. Okay, it takes in a var expression. I like the other way. Var. Here, we'll use variable naming conventions for this. So var exp and lambda exp. So that's the parameters that guy takes in. And then he needs to build for us what looks like a lambda expression. And what does a lambda expression look like? Okay, so it's a list that starts off with the word lambda. Then what? Well,
Another list of the var.
then a list containing our var expression. Then what? Our lambda expression. So I can now call my lambda expression constructor, passing it my var expression, so var exp a, and then also passing it another lambda expression. Okay, but this kid's going to get recursive real quick because we don't have a lot of ability. So let's just pass it a second var expression for right now. Is a var expression a lambda calculus expression? Come back here real quick. This is a LC expression, one of these guys, not necessarily a lambda expression. All right, so our function here takes in a var and an LC expression, not a lambda expression. So it can be any of those three productions. So to make this match, we'd probably call this guy LC exp. So lambda expression takes in a var expression, another lambda calculus expression, and it builds the list containing the word lambda, the list containing var-exp, and a lambda calculus expression. So we'll go ahead and call lambda-exp with this, and it's going to build for us. Oh, I need to actually finish building my var expression. It's going to build for us the list containing lambda, a var expression, and lambda calculus expression. Why did this show up like that? And why did this show up like this? What does this guy do? So everything in there should be treated as just elements. Don't process them. Okay, so when we quote something, we say don't execute. So, make sense? So that's why we get this thing literally says the word var expression and literally says the word LC expression. It didn't give us those values. So what we're going to do here is we're going to create a list out of the word lambda, out of the list containing our var-exp and our LC exp. Make sense? Last production is an app expression. So we need a constructor for an app expression. App expression takes in two LC expressions and returns what? A list of those two LC expressions. Define app-exp to be a lambda that takes in an LC-exp1 and an LC-exp2, and it returns a list of LC-exp1, LC-exp2, like that. And now we can see this guy at work because I can go ahead and I can say let's build a app-exp, passing it that lambda calculus expression and passing it, let's just do another identical one. We'll pass it a C. All right, so now we have a lambda expression with a parameter A whose lambda calculus expression, whose body is an app expression that has this var expression and this var expression. There's my lambda, here's my parameter, and here's the list B and C. Those two guys. All right. Now, if we were to update some of our variable names here a little bit, just to kind of make them more programmy sounding, we're going to say that this guy is the body. Okay. This guy is the param. So just change the variable names a little bit, but you see how we're starting to connect it back to what a language is? Here's our parameters for our function. Here's the body of that function. Similarly, here's the rater. Here's the rands. This is the operator. This is our operands. Make sense? let's start off with something like that. We'll create it kind of a simple one. Go ahead and run this. Oh, can't call it exp. And exp. Call it that. That'll work. All right, so I've created this variable called exp. And this guy holds kind of the string version, if you will, of a lambda calculus expression, right? Not in terms of our constructors, but in terms of us just writing it, as if we were writing the scheme. So we might write a function called parse expression. And what parse expression might do is it might take something that looks like this and turns it into the equivalent constructors. So maybe we define parsed to be what? A lambda exp. So let's just make the equivalent of this. So it's the lambda exp, which takes in as a parameter a var exp. We'll pass that guy an x. This could be the identifier x, as well as a body, which in this case is going to be an app-exp, which takes in a var exp a and a var exp b.
Oh, that's what it should return?
Yep, yep. So here, let me just kick this down a line so we can kind of see the pieces. So if this is our unparsed version of a lambda calculus expression, kind of writing it in English string format, list format, and then this is our parsed version, which is taking that string or list input and turning it into the equivalent constructors to build it. All right, so we'll look at both of these. Okay, so exp looks like that. Parsed looks like that. Generated the exact same output, right? Because we called it in terms of all these constructors. Okay, so if instead we put a little dot in front of it there, and exp and then parsed, this gives us the parsed version of that guy. So it gives us what our call to all our constructors would be. Does that make sense? So if I were to copy all this stuff right here, I would ultimately be able to get, well, actually, I would probably have to do an apply on that. So let's just do this. Apply parsed. I'll have to apply a function to it. I don't want to do that yet. That'll give you a magic trick you're not supposed to have. All right, so.
Wait, apply?
No, apply would have been fine, but the thing I'm going to actually have to use for this, to do this, unimportant to what we're doing now, because we ultimately want our output to look like this. We want to take something as input that looks like this and turn it into this. Make sense? So we're going to walk through the lambda calculus expression. We're going to write something called parse exp that walks through something, an input that's in this format. All right? Walks through an input that's in that format and constructs the calls to the constructors that will ultimately produce this format. So parse exp converts this to this. Make sense? All right, so this is kind of putting our two pieces together of things we've been dealing with lately. We've been dealing with this idea of building data types, building constructor versions of our, various objects that we might have. In this case, we have a var exp, a lambda exp, and an app-exp. And then what we worked on before that was this idea of walking through grammars. So now we want to walk through a grammar and have the output be the equivalent constructors called in the right order to produce that equivalent expression. Okay? So we're going to do a define parse-exp here. And parse-exp is going to be a lambda, and this guy is going to take in an expression as a parameter. Okay? Actually, let's call it an LC exp, lambda calculus expression. Except using my naming conventions, I would have called it this, right? Is that what you were going to complain about? Good boy. I'm actually serious. Yeah, we want to have good naming conventions. All right, so define parse-exp, lambda LC expression. All right, now we're going to have a series of cons for each of our productions in our grammar, right? Okay, first production is we're looking at a identifier, right? How do I detect whether LC expression is an identifier? Symbol LC exp. If it's an identifier, what do I return? Remember, my output of this thing is going to look something like this. Okay, so I'm going to return, where am I at here? Var exp, passing it LC exp. But what's that going to do? That's going to actually call my constructor. I want it to ultimately produce this guy. Okay? So what do I need to do here? I need to do a list containing var exp along with LC exp. Right? That'll build the words that I would need to type in if I wanted to build a var exp, rather than actually having to evaluate var exp for me. So parse exp is going to take lists and symbols version of our lambda calculus expression and convert it into data type, data structure version of our lambda calculus expressions. Guess what's coming next? Unparse, right? So after we finish this one, we're going to reverse the process. So parse of unparse should give us the original. All right, so that's our first production. If I'm looking at just an identifier, then build me the text I would have to type in order to generate a var expression, rather than actually call the constructor. Next guy, I want to know if I am looking at a lambda expression. Lambda expressions look like this. So somebody who usually doesn't answer, help me write this code. Because clearly we already have a group here who's catching on to this stuff, and if you're always just fed the answers, we aren't allowed to critically think for the rest of us. Let's start with this. How do I know whether I'm looking at something like that? Okay, so you can say if I see one of these and one of these. What about this guy right here? Okay. How many of these productions have the word lambda in it? How many of these productions, just the stuff I have highlighted, how many times do you see the word lambda there? Once. So only one of our productions has the word lambda, right? So if I'm not looking at just a symbol, I know I'm looking at a list, correct? My other two productions are both lists. If the car of that list is a lambda, I must be looking at this production, correct? Could the car of this list be a lambda?
No, it can be a list that had the...
Yeah, it could be a list that has a lambda. So the car of this guy could be this whole production, but it would start as a list. So the car of this guy would either be a list or it would be an identifier. So I can detect this production by just saying, is the car of my lambda calculus expression, the guy that was passed in, is it equal to the word lambda? I don't need to check these other pieces. I can assume it's accurate stuff passed in. Now, if you wanted to be real, specific about it, you would want to make sure that they created properly written lambda expressions. So that means that they require to have the word lambda, parameters, a parameter list with exactly one parameter in it, and then a lambda calculus expression. But we're assuming they're giving us some correct code, so we can uniquely identify this particular production by just looking at the lambda. Make sense? So how would I write that? How would I ask if the car of that guy is lambda? Such a talkative bunch. I'm giving you a nice simple little question. I just want to know if the car of this guy is the same as the word lambda. Like that? Perfect. So this guy will boil down to true if this value, the car of my LCA-EXP, is the same as this word. If that's true, what do I want to do? If I'm looking at a lambda calculus expression, if I'm looking at production 2 of my lambda calculus expression, that is my lambda expression, I want to build the text that will be required to actually call my lambda expression constructor. So my lambda expression constructor requires what inputs? Parameter and a body. Okay, needs those two guys. All right, and what is it ultimately called? It's called lambda-exp. So to call this guy, I would call lambda-exp, passing it a param and a body. All right, so let's start off here. We're going to say we have our list containing lambda exp. That's the name of the function. Now I need to get the body, or I'm sorry, the parameters. How do I get the parameters of my of this guy? So that guy looks like this. He's one of these dudes. So I need to figure out, how do I extract this part? How do I extract this part? So in this list right here, how do I get that piece right there? Go ahead. Okay, so the car of the cooter of this guy gives me the list that has an identifier in it. Okay, so now what do I need to build with that? So this guy 100% of the time is guaranteed to be what kind of animal? An identifier, or in our constructor world, a var expression. What do I need to build a var expression? Just an ID. So I need to get just this piece. So how do I get just that piece? The car of the cooter. Okay, so if I take the cooter of this guy, I'm left with the list containing that crap. If I take the car of that, I'm left with this list. If I take the car of that, I'm left with this identifier. And I want to pass that identifier into the constructor for building a var expression. Right? All right, so again, we're generating the text here. So I'm going to create a list. Actually, let me kick this down a line. Containing lambda expression. Then a list containing var expression. And the second element of this guy is going to be what? The car of the cooter of the LCEXP. right? But let me ask you this. Isn't this guy a lambda calculus expression? Sure. So could we call lambda calculus expression on that guy? Or I'm sorry, could we call parse-exp on that guy? And have him produce for us the list var-exp, this guy? So instead of doing this, can't I say parse-exp, passing it the car of the cooter of lc-exp, and let that ultimately boil down for me to this? This particular case, it wouldn't make a difference, but certainly going to be helpful starting to get our mind thinking like that for the rest of the productions. All right, so I'm going to create a list whose first element is lambda-exp, whose second element is whatever's returned by parse-exp on the car of the cooter, and what? Whatever's returned by parse-exp on, how do I get this piece? The CADDR, the car of the cooter. So take the cooter, get you this guy. Take the cooter of that, get you the list containing this guy. Take the car of that, get you just this guy. So this is going to be the car of the cooter lc-exp. So we'll call parse-exp on that. Make sense? Now, by our definition here, tell me why our current code technically allows us to create illegal lambda calculus expressions. Even though I told you that we should start thinking like this, tell me why that particular line I have highlighted, that particular piece, is inappropriate.
Because then that doesn't necessarily have to be a var expression in there. It could be anything.
Yep. Yeah, so even though I tricked you into doing it just to get our mind thinking about we need to recursively call this guy, now we need to go back and relook at this and say, this guy has to be a var expression. He has to be that exact kind. That makes sense? Otherwise, it's not a legal lambda calculus expression. So we're not allowed to have another lambda production in here. We're not allowed to have an app expression production in here. It has to be a var expression. And as we have it written right now, because we're passing it on to parse-exp, it potentially would allow us to put in a lambda expression or a app expression, and it would go through the motions and produce for us the apocalyptic masterpiece that would be a broken lambda calculus expression. Now, having said that, if I change it to what we had before, does that make it any better? Or does that still allow us to write illegal expressions? Okay, but it'll allow us to write illegal expressions, but it'll give us pushback, right? It'll give us an error if we give it a bad expression. Does that make sense? So if I allow us to write any sort of lambda calculus expression and we pass it to parse-exp, which accepts any lambda calculus expression, this guy will always be a legal line. But if I actually piece out this and I create a list containing var-exp and the CAADR of lc-exp, then I'm okay so far. Make sense? So for a lambda expression, if I'm looking at a lambda, let's create a list containing the word lambda-exp, followed by a list containing the word var-exp, followed by the actual identifier that was in there, because this guy has to be a var-exp, so we're not going to rely on parse-exp to deal with it, followed by whatever parse-exp returns for the body, the lambda calculus expression that is the body, which could be any kind of lambda calculus expression. All right, so that is if we're looking at a lambda production. If we're not looking at a var expression production, and we're not looking at a lambda expression production, we must be looking at what kind of production? This dude, an app expression. That is a list of two lambda calculus expressions. So how do I rate this part?
Just call parse on the first part and on the second part.
Okay, and create a list out of the two. Anybody have a suggestion for a cool way of doing this? What would the cool kids do for this particular one?
Use the built-in functions.
But you have to use a built-in function you know about. So what would the cool kids do to apply the lambda calculus expression function that we've written to every element of a list? Map. So we can map LC-exp onto, map parse-exp onto LC-exp. Because if we're in this case, we know LC-exp is a list containing two lambda calculus expressions. So we're going to go ahead and map our function parse-exp, which takes one input, so it's appropriate for map. And we're going to map it to every element in this guy, which we know is going to be 2. Make sense? Now, if you don't like that version of the implementation, you don't want to do the map thing like the cool kids, you can do this. You can create a list containing what? Containing parse-exp on the car of LC-exp with parse-exp on the catter of LC-exp. I'll do the same thing, right? We happen to know that if it's legal code that there will be exactly 2 lambda calculus expressions in there. This gets us the first one. Go ahead and pass it to parse-exp. This gets us the second one. Go ahead and pass it to parse-exp. Create a list out of the 2 things returned by those guys. So whichever one of those makes you happy. Okay, so is that it for parse-exp? So if I call parse-exp on an exp, if I call it on this guy, it should give me what parsed was, right? Gives me a list containing a lambda-exp, which has a list containing a var-exp, which has a list containing a list var-exp-a, and a list containing a list, or I'm sorry, just the list var-exp-b. So this is our app expression, a var-exp and a var-exp. This is our identifier, var-exp. This is our lambda expression. Lambda expression, this constructor takes in parameter and body. The parameter is this var-exp. The body is this what did we forget? Here, I'll print out parsed for you. The word app expression. Okay, so this last guy here, we're creating a list out of app-exp, and then whatever parse-exp returns for the other two. You'd have to use an append. So yes, you could. And so now we're going to do parse-exp, passing it an exp, and that gives us this guy. A lambda expression constructor, which takes two parameters. The first one's going to be a var expression constructor. The second one is going to be an app expression constructor, which takes two parameters. And this one's going to be a var expression constructor, and this one's going to be a var expression constructor. Make sense? Okay. So, now, what if I want to write unparse-exp? So now we'll take something that is the output of parse, so something that looks like this, and it turns it back into something that looks like this. Undoes the parsing. So we're going to create a define unparse-exp to be a lambda that's going to take in a lambda calculus expression. Let's actually call this a lambda calculus I don't like data type because that's the other stupid thing the book uses. Yeah, I like that. Lambda calculus struct. It's very, feels a lot like C and C++. I like that. Okay, so lambda calculus struct, and it's going to turn this back into list and symbols. LC struct, yeah. All right. So now, what are my possible productions? So I'm going to use the same pattern, right? I'm going to use a cond. First thing I might be looking at is what? Okay, something 100% of the time. Am I dealing with lists here? Definitely. I'm definitely dealing with a list here. Okay, so I'm going to look at the car of that list, and I want to know, is it a var-exp, or an app-exp, or a lambda-exp? Which of those guys is it? Okay? So we'll go ahead and we'll say, if the car of LC struct is equivalent to var-exp, then what do I return? So this would be a var-exp, so that means I'd be looking at something like that. Oh, the catter. Okay. All right. So, actually, I like that approach. We could choose to do this, right? I could choose to say, well, let's just boil down to the catter of LC struct. That's good enough. That'll just give us the identifier, right? But instead, what he said is, you know, I already have some tools that will do this for me. So I'm going to go ahead and I'm just going to say call var-exp on the catter of LC struct. So if I'm looking at a var-exp, let's go ahead and leverage our constructors for building us a var-exp. else if I'm looking at a lambda exp, what will I do? Lambda exp is going to look like this. So when the car of it is lambda exp, then I want to call my constructor for lambda exp, which takes in the parameter and takes in a body. My parameter is this guy right here. How do I access that guy? Catter. So we're going to call this guy a lambda exp on the catter of LC struct, along with the, how do I get this guy? CADDR. Just kick this down, CADDR LC struct. Make sense? We'll take this, the cdr of the cdr, which is going to give us the list containing this last guy, and we'll take the car of that to get us the pull that piece out.
Don't we have to take the car of the CADDR for the var expression because it's var expression and then the variable?
If the car of this guy is this, the catter, or the cdr of this whole list would be this, and the car of that would be
The list of that. But you don't want to pass the list.
oh, we want to pass it just the identifier.
Yes.
Yeah, so the problem is we get this piece out of this, where we need to get just this piece out. So you want the car of the cdr.
Yeah.
Cdr gets us this, car of that gets us this list, and then, oh no, we want the,
That's for the
let's think about this one. Okay, so the cdr gets us this guy, the car gets us this list. We need to get the x out of that list. So we need the cdr of that list and the car of that. Oh, that's a fancy schmancy one. Okay, so this is the, so we want to take the car of the cdr. So cdr gets us this whole thing. The car of, well, let's just take one piece at a time. Cdr gets us all this. The car of that gets us this list. Then we're going to take the cdr of that and the car of that. Right? So I have this list, take the cdr of that list, giving me this, take the car of that, which gives me the x.
Will that one work?
Like, is it a thing? This is the question. I think so. I think this one's a thing.
I thought we had tested it.
I think that one's just short enough.
Well, I guess we're going to find out. Is this a thing? So we're going to take the car of the cdr. Actually, we're going to take the car of the cdr of the car of the cdr. It broke?
Yeah, it doesn't recognize cadaver.
Those idiots. How do they not understand?
All right.
Would that be the catter of the catter?
Was it list ref gives me, I need to do the list first, then the index. So list ref, I'm going to pass it LC struct and say give me the element at position 1, and then give me the list ref of that and give me the element at position 1. Won't that do it?
Yeah.
This is 0, this is 1. Oh, I want position 2 for the first one. No, wait. No, this is 0. This is 1. So I want position 1. That gets me this list. And then I want position 1 from that list, which is 1. You guess right. So I'll use list ref here so that I don't have this, you know, horrifying car, cooter, blah, blah, blah. This is saying give me bucket 1 from LC struct. It's possible we have to flip these two. I don't remember if this is if it's list then index or index then list. All right, so this will give me that element, which will be a list for us, and then we're going to say give me the element 1, which is this guy, from that list. So we're going to call lambda expression, passing it, in this case, our x. And then we're going to call, let's just use the same format for the second piece. It's easy enough to follow. So we're going to say list ref 2, give me, let's see, this is the entire guy, so we need to go ahead and call I don't need the outside pieces, right? I need to call unparse-exp on the rest.
Couldn't, instead of using the list ref twice, you just call the catter of the catter? C-A-D-R.
Yeah, I could.
And that would be slightly less messy.
So we're going to say unparse-exp, passing it this list. All right, so if I'm looking at a lambda expression, pass it, call lambda-exp, passing it as its first parameter, just an identifier. That is the identifier by grabbing this list, then this element from that list. So that's what this will boil down to, like an x. And then whatever's returned by unparse-exp on list ref LC struct 2. So this guy 2, which is the cooter, the car of the cooter, C-A-D-D-R. So if you'd rather use C-A-D-D-R here instead of list ref, you can. All right, so that's for a lambda expression. Else, we must be dealing with an app expression, right? If we're dealing with an app expression, what are we going to do? We're going to call app-exp. An app expression takes in two LC expressions. So we're going to pass it the unparse-exp on the car of LC struct, along with unparse-exp on the catter of LC struct. All right, so if I run this, let me just go ahead and type out an exp first. That looks like that. Then let's call parse exp on an exp. Looks like that. Then let's call unparse exp on parse exp of an exp. Car expects a pair given app expression. So we have something broken in our.
Yeah, I thought that was going to happen when you. I think it's on the second time that you call. It's just below where you.
Yeah, so let's walk through this. So for unparse expression, we originally pass in something that looks like this. We ask, is the car of this guy a var expression? It's not. It's a lambda expression. So we come into this guy. So we're going to call lambda expression, passing it list ref. So this guy right here. Yeah, it's funny. List ref is actually implemented in terms of cars, so the error is coming from a car inside of list ref. I think. Or is it this car? I don't think it's this car. Let's see.
When it-
So let's assume we get this, and let's assume then we get this. We are not calling unparse on that, so we're okay with this. This is not getting sent into unparse. This guy, though, is getting sent into unparse, so we're getting list ref 2, which is this whole piece here, whose car is app expression, this guy. So then we're calling unparse expression on this, which should work. And we're calling unparse expression on this, which should work.
Isn't the car giving you app expression?
Yeah, right here, the else.
Yes, that- the, like,
Oh, yeah.
the list is
We didn't piece it apart like we did up here. We weren't looking for the car. We're just in the else. So when we say car here, we're getting this. What we actually want is the car of the cooter. We want the car of the cooter and then the car of the cooter. So this is the car of the cooter and then the car of the cooter. Like that. So now we should be able to call unparse exp on parse exp on an exp, and we get our original. Make sense? Okay, so here's unparse and parse exp along with constructors for var exp, lambda exp, app-exp. For your homework, take all this stuff, expand this to support lambda calculus expressions that have more than one parameter. So instead of a lambda calculus expression that takes a single parameter, make this work on lambda calculus expressions that take in 0 or more parameters. So you might have an identifier, you might have 30 identifiers in there. Make sense? So I give you this as a starting point, but now you can't just assume you have a single var expression in there. Now you have to explode out that piece and say how many var expressions actually live in here. Make sense what I'm asking you to do? All right, so I'll give you this code as a starting point. This it up on Blackboard, and this is due by like midnight tonight. So this will be due before class starts on Tuesday.
Can I see the unparse?
No, fortunately. And I am going to put it up on,
Okay.
yeah, I'll paste it in with the homework. So, yeah. So if you weren't following along, or chances are there's a lot of diarrhea of parentheses here, you'll have this as a starting point. Okay? We're probably also getting fairly close to when we need to start submitting our work through GitHub. So I have some way of, now our thing getting a little bit longer. So I think when I paste the stuff in, it actually looks okay, doesn't it?
Yeah.
So it has something to do with how it works on the submission side.
Copy it into Word and then copy it in.
If you copy it, if you put it in Slack and you do it in Slack and then you copy it in, it's so much cleaner.
Yeah.
Okay.
Or if you
Because
copy it into
Slack
Word
has
and
a coloring or tab thing. If you do scheme and then you paste your code into that, you can put it to yourself.
Okay. But I guess whatever, when you go to turn it in now, we'll don't worry about GitHub for this assignment because I don't want you to have to deal with more than one thing right now. But you know, try to paste. You said pasting it into Word first and then copying it out of Word into the thing works. All right, so do that for your assignment because now we're getting to the point where it's going to be a little tough for me to pull it out of the the cluster comment. All right, but it does work when I paste it in, right, from here. I wonder what the deal is. So I guess whatever. Here, just in case. There, I put it on Slack, so you have that code in Slack in a decent format. And then I'll also post it with the, actually, no, I'll post it with the assignment so we can find out if it looks good, but it at least looks like it's up there. All right, I'll see everybody on Tuesday.